Hello. Good evening, everyone. Am I audible?
Yes, ma'am.
Yes, good evening.
Okay. So today we are going to discuss mock discussion. Okay. So I hope you guys have solved these questions given in the mock, right? Let's start. So how was it like the questions in the mock? Did you guys comfortable with these examples or not? The level and all. So here is the first question. Suppose Manoj owns a light bulb manufacturing company and determines that 3 out of every 75 bulbs are defective. What is the probability that he will find the first faulty bulb on the sixth one that he tasted? So, how to start with this one? Any idea? So, you guys have, I hope you guys have solved, so you may have opinion on all the questions, right?
Geometric distribution.
It's a geometric distribution.
Yeah, geometric distribution. And what will be the parameter for that?
3/75 probability.
Yeah.
Yes, ma'am.
Okay. So, uh, can you just create random variable for it? X will be a random variable. How to define that? We know that X is following geometric distribution with the probability P is equal to what?
3/75.
3/75, which will, sorry, 75, which when calculated will give us something 0.04.
0.04.
Okay, 0.04, right? So this is geometric distribution with 0.04. And we are interested to find what is the probability that the sixth bulb is defective, right?
X is equal to
So
6.
using the probability formula, you will be able to calculate it.
P into 1 minus P to the
Yeah.
power K.
Yeah. So may I say it as like 1 minus P raised to the power 5 times into P, right? Sixth bulb is the first success, right?
Yes, ma'am.
Sixth bulb should be a faulty, so will we fade in the initial 5 terms, so 1 minus P raised to the power 5 into P, right? So 1 minus P, 1 minus 0.04 raised to the power 5 into 0.04. Fine. Then we'll just calculate it and what we'll get? 0.04, that means 0.96 raised to the power 5. Fine. And rest is the calculation. Isn't it?
Yes, ma'am.
So just tell me, if we can solve these things. Okay, this is just a calculation kind of things, but just for extra information, what should be your X? Like X is following geometric distribution, that's a different story. How will you define your random variable? How to define it?
X takes the value 0 to infinity.
X
6
takes the
to
value.
1 to infinity.
What? See, just read the question. Random variables are the definition, what the values it's going to take. So you are giving me the range that it can take value 1, 2, 3, and so on. But when I say X is a random variable, then define it. For example, if I say F is a function, then I have to give the definition that it's starting from R to R, and F is defined as f of X is equal to X square or something, right? So here, what are you calculating? That should be your definition, right? X is a random variable, which is denoting what?
A geometric distribution with parameter 0.04, and we need to calculate the sixth success probability success in the sixth position.
Can I say it as a success on obtaining the faulty bulb?
Yeah, that is our success. Faulty
Or
one is getting, yeah.
success on obtaining a faulty bulb. Fine. Faulty bulb, or you just can say it as a getting first faulty bulb. That is also fine. Okay. By so my random variable was success on faulty bulb, or let's say getting a faulty bulb. Yeah, faulty bulb, and then according to question, I decided okay, it's the geometric distribution, and rest of the things we calculated, right? Isn't it? So probability x is equal to 6 means if I frame a sentence, then what? Getting a faulty bulb on nth time, right? Nth turn. Is it fine now? Will it make sense? So probability x is equal to 6 is what? Probability of getting a faulty bulb on 6th turn, right? Isn't it?
Yes, yes.
Yes, ma'am.
So that's what the definition of random variable I was talking about. So then let's see for the next question. Yes, you can unmute yourself and speak.
Madam,
Can you summarize this question? Actually, I joined late.
madam,
Yeah.
why what's it? 75C, we do not take 75C3.
Sorry, what?
Uh,
75 C3 means okay. See, it says there are 75 out of 75 bulbs, 3 bulb will be a defective, right? So if you calculate 75 C3, what does it give you? It's a common number of combinations, right?
yes,
75 C3 will provide you the sets of 3 bulbs that may be the possibility that these are the possible combinations of bulbs, right?
yes,
So will not work here. What we were being asked is what is the probability that when he or she picks it's Manoj, right? So he will pick a bulb, and initially 5 bulbs are not faulty, but 6th one is the faulty. So
yeah,
in this kind of things are described in geometric distribution, right?
yes,
And probability is out of 75 bulbs, every 3 bulbs are defective or faulty. So 3 by 75 is probability. And then as we know that x is following geometric distribution, so probability x is equal to 6 is given as 1 minus p raised to the power k minus 1 into p, right? What is, if x is following geometric distribution, then what is the probability that x is taking value k? 1
one
minus, yes?
1 minus p k into k minus 1 into p.
Is it into, is this raised to the power, no? K minus 1 into p, okay? Fine. So that's it. So we just placed all these values and calculated it. So that's all. Okay. Any doubt here?
No.
Oh, so let's move to the next question. Let x be a continuous random variable which PDF fx is 4x cube in the range x0 to 1. Then find the PDF y is equal to x cube. So yes, how to proceed with this kind of questions when x is a continuous random variable, its PDF is given there, and there is a function of x, and we are interested in finding out the PDF of that new function. How to do that?
Using the theorem. Would go with formula.
Okay. Anything else? Which formula?
1 upon mod of
Monotonic.
G inverse X.
Yes, as a given distribution is for x cube, right? So x is a continuous, and we are interested to calculate the PDF y is equal to x cube in the range. What is the support of x here? 0 to 1.
Zero. Yes.
So x cube is a increasing function, right?
Yes, ma'am.
So it's a monotonic function and also differentiable, right? X is so y is equal to x cube, that is y is what g of x. Y is equal to g of x is monotonic and differentiable, so we can use that formula, that theorem. What theorem says? If your x is a continuous random variable and there is a function of random variable x which is monotonic and differentiable, then PDF of a new random variable y is nothing but 1 upon modulus of derivative of g prime at a point g inverse of y, right? Into
Yes, ma'am. Fx
PDF
of D inverse of
g inverse of
y.
So we have here y is equal to g of x, which is equal to x cube. So g of x is equal to y and it is x cube. So what will be the g inverse of y here?
X is equal G inverse of y is equal to y x to the power 1 by 3. So the y to the power 1 by 3.
Okay, just a minute, okay? So yeah, what will be the g inverse of y here? Y raised to the power 1 by 3.
Yes, ma'am.
Okay. So anyone has doubt here that why I wrote the g inverse of y is equal to y by 3, y raised to the power 1 by 3? As we
Ma'am,
discussed,
can you please explain this?
yeah, if g of x is equal to y, then if I take inverse on both sides, see, we cannot take inverse every time, right? That's why the monotonic and differentiability condition is put on there, so that your function will be bijective on that range. So its inverse will exist. So just take inverse on both sides on this format. What will you get? X is equal to g inverse of y, isn't it? If you apply inverse on both sides, what will you get? X is equal to g inverse of y.
Yes.
So your if y is equal to x cube, then what will be its inverse? X will be equal to y raised to the power 1 by 3, right?
Yes.
So that's why we can take it like that. Okay. So g inverse of y is here. What will be the different derivative of g dash of x? Yeah.
3x square.
So it's a ddx of x cube. So it's nothing but the 3x square. So
Ma'am.
yeah.
But it is a 4x cube, no? So no need to take 4.
What 4?
Fx of x is
No. We will take it. So g inverse of g derivative is this one. Inverse is this one. Now from given data, what we have, the PDF of y will be 1 upon modulus of derivative of g at a point g inverse of y into PDF of fx at g inverse of y. So now someone asked, right, where to use that PDF. Now PDF will be used here. What is fx of g inverse of y here? So is it okay if I put directly the value of g, derivative of g at a point g inverse of y? What is derivative of g? That is 3x square, right? See,
Yes, ma'am.
derivative of g derivative x is what? 3x square. So what will be the g derivative at a g inverse of y? So you have to just put g inverse of y in place of 3x, in place of x.
3 into y to the
That
power
is
2 by
y,
3.
yeah. This g inverse of y is y raised to the power 1 by 3. So 3 into y raised to the power 2 by 3. Fine.
2 by 3.
And if your fx of x is 4x cube in the range 0 to 1, that's what we are dealing our PDF of y in the range 0 to 1 only. So
Then 4y.
yeah. So what will be our fx of g inverse of y?
4y.
4y.
Just putting value y is equal to y raised to the power 1 by 3 at place of x, right? So 4 into y. Fine. So just putting all this value in this formula, what we'll get? Fy of y is 1 upon 3y raised to the power 2 by 3 into 4y. Fine. That's it. Now we can solve it. That is nothing but 4y raised to 1 minus 2 by 3. So it will be y raised to the power 3. Sorry, 1 by 3, right? 1 by 3. That's it. Okay. So by using that theorem, this is quite easy, right?
Yes,
Ma'am,
ma'am.
don't we put the G inverse in the range?
G inverse in the range, which range?
In the PDF range, I think in the revision session they put it in the range.
I didn't get what.
No, the PDF we have a range from 0 to 1, right?
Yeah.
So don't we have to put the y there?
No. Like you're asking to put this G inverse of y in the range. What is range here?
Yes. No, the in the support from 0 x is greater than 0 and less than 1, right? So
Yes.
in that case we have to put, right, we have to equate y right there. You didn't equate it in the in your document.
Just a minute. Just a minute. Yeah. Where are you talking?
You can see there is a G inverse y, right? No, in the bottom itself.
Okay.
There we put the G inverse value in the PDF format, right?
PDF format?
No, there is a PDF formula, right? 4x cube.
For
So there we replace, there we replace x value with the y value, right?
Yes, y raised to the power 1 by 3.
Yeah. So don't we replace the y value in the range also?
Where is range?
0, x is greater than 0 and less than 1.
Okay. Fine. So, see, whenever your x is ranging between 0 to 1, okay, and y is equal to what? X cube, right? Then what will be its range?
Same.
0 to 1, right? So you can
Okay,
write
okay.
this as like this. Like PDF in this. See, it's a PDF of x in terms of y, like G inverse of y. That's why we wrote it here. But when we write a PDF of y, it will be like GFY of y is equal to what? 4 by 3 y raised to the power 1 by 3, 0 less or equal to y less or equal to 1, and 0 otherwise. So you were asking like this one,
Yes,
right?
ma'am. This,
If I am writing 4y here, then whether to put y raised to the power 1 by 3 lying between 0 to 1, isn't it?
yes, ma'am.
That was
That's
your
what I
question?
was
Yeah,
asking.
yeah, yes,
Yes.
correct. So see, we do not write the range of y raised to the power 1 by 3, so we write it as a 0 to 1. Okay, fine.
Yes,
In
ma'am.
terms of y also
Just
it will take.
one doubt in this question. So what we are given with y is equal to x cube. From
Mhm.
this, we have to derive that derivative of g,
Mhm.
like in terms of g inverse of y, right? That is what the
Yes.
ultimate. First, we have to derive that from this, right?
Yeah.
And how to get the second value, like uh, that marginal, I mean, fx of that what is given here is that PDF of x in terms of y.
Yeah.
The second part, how did you get that fx of g inverse of y?
Mm-hmm.
I'm
Sorry.
just asking
Effects of.
how did you get this value fx of g inverse of y?
So just put your g inverse of y values in. See, what is g inverse of y? X is equal to g inverse of y, isn't it?
Hmm. Right.
So if I have given with fx of x, and I want to put instead of x, I want to put g inverse of y, then what will be fx of x is 4x cube, right? So instead of x, I will put g inverse of y. That's it. So it will be 4 times g inverse of y raised to the power 3, right?
Yeah.
That's how function works, right?
Yeah. Yes.
So
Yes.
4 into g inverse of y raised to the power 3, which will be what? 4 into y raised to the power. This is y raised to the power 1 by 3 into 3. That is nothing but 4y.
Okay. To get this portion, we actually need to replace the x value with y in the PDF, and that's it.
Not
Actually,
x, not we are not replacing x value with y. X value replacing with g inverse of y. Okay.
okay. Okay. Okay. Okay.
Okay. So there is also one another way that is a manual way to calculate a PDF. What is that? In case you do not know whether to use a monotonic function or, but still, if you know the theorem, that will make your life easy because that's not that much tricky. Once you know how to calculate G inverse derivative and just PDF formulas. Okay. What if so your PDF for x is 4x cube, fine. So we can do one more thing, that is just calculate CDF of y. Okay. That will be what? Probability that y is taking value less or equal to small y. Fine. What is capital Y here? X cube.
X cube.
So we can write it as x is less or equal to y raised to the power 1 by 3. Okay, fine. We know the distribution of x.
Yeah,
Right?
it is from 0 to 1.
This is PDF.
Yes, ma'am.
Oh, sorry. Okay, PDF is given to us. And range of x is from 0 to 1. Right? So what we can do is integrate it from 0 to 1 fx of x dx. Okay? Y raised to the power 1 by 3, sorry. Because we are calculating CDF till y raised to the power 1 by 3, this much only, okay? So what will it give? 4x cube dx.
Ma'am, are you doing the previous one question?
Yes, the same question in the manual method. Okay, so 4x cube integrated with respect to x, what will you get? 4 by 4 by 4, right? Y raised to the power 1 by 3, just put all this value, okay, 4 get cancelled, and we will be left with y raised to the power 4 by 3. But don't forget, this is what? Fy of y, that means CDF of your y. But we are being asked to find PDF. Then how will you give the PDF?
Again, make
Differentiate
derivative of
this.
this. Differentiate this.
Yeah. And PDF will be given by small f, we denoted, and it's nothing but the derivative of your CDF with respect to y. That is nothing but, isn't it matching the same question, like same answer as above?
Ma'am, one doubt here.
Mm-hmm.
Ma'am, when you integrated it, where did where did range of x go? Why did we put y there?
0 to y raised to the power 1 by 3.
So, ma'am, but range of x is between 0 to 1. We don't know why if it is equal to 1 or not.
Yeah. That's why we just put y raised to the power 1 by 3. Now whatever the y value will be there, we can put it accordingly.
But x can't go till y, right? If y is greater than 1, then x can't go till y, right?
But will our x see, x cannot go beyond 1, right? And the range and y is defined based on x. So how y can go beyond the x?
Oh,
Is it possible? Y is defined as x cube,
yes,
isn't it?
understood.
So restriction is on y, not on x. Okay, fine. So the next one is, so this was the manual method. If you know how to use the theorem, you can go with that also. That is fine. Actually, that is the easiest way and fast method.
And ma'am, suppose it would not have been a continuous but a discrete random variable, then what we would have done?
Which one, x or y?
X. Sorry,
If
x.
If x is a discrete random variable, then you can't use the theorem. Why? Because the theorem, whenever you use any theorem, then whatever the necessary conditions are there, that should be satisfied by your problem. Otherwise, you can't use it.
The original method where we took CDF.
Where you do CDF. In that case, for discrete random variable, we have to sum up all these things. We have discussed these things, right, in like previous portions. When you have a discrete random variable and then you were finding the PDF of functions of that random variable.
Okay, ma'am.
Do you remember that?
Ma'am, actually, I wasn't there in the session. I'll rewatch it.
Okay, fine. Around some week 3 or week 4, that portion was there in quiz 1. Fine. So let's say next question. XY is following uniform over some D, where D is this region. Then what is the marginal density of the marginal density function fx? So, yeah, any idea?
First, we have to find the area.
We'll find the graph.
And find the graph. Okay.
And the area is 1 by D.
Area is 1 by area of D, right?
Yes.
Yeah. So how did you get to know that area will be 1 by D?
Because it is uniform.
And because it's given that XY is following uniform distribution over D. Right? And D is what?
Area.
Collection of all the XY such that D is not area, D is the region. Yeah, what it was? X plus Y is what, less than or greater than?
Less than 3.
Yeah, less than 3.
X is greater than 0, Y is greater than 0.
Yeah. So from this information, we know that fxy will be
1 by area of D.
1 upon area of D. Okay, is it fine if I write it? I should write area of D, right? Area of D, but till what? Like, what will be its range? Like, it will not be the 1 upon area of D on the whole R, right? Yes.
Ma'am, that we can find
on
out.
The given, right? X plus Y, yeah, less than 3, and X is greater than 0 and Y is greater than 0. Okay, and 0 otherwise. All the points lying in this set.
So both the limit will be till 3.
Yeah.
3 open brackets.
Yes. 3 open brackets. Correct. So just calculate area of D. To calculate area of D, we need to find what is the region defined by this D. So x plus y less than 3, that means we have to plot first x plus y is equal to 3. So let's say 3 somewhere here and somewhere here. So as it is strictly less or equal to, so I am having the lines, dotted line, okay. X plus y equals to 3. So which region will be our required region? D.
Below 1.
Below 1, right? This one. So this is our D. So area of D is what? It's a triangle.
Into height.
So half
Half
height,
into 3
height
into 3.
into.
Half into base into height. Base is 3 and height is 3.
Okay, fine. So 9 by 2. So fxy will be something
2 by 9.
2 by 9, yeah.
2 by 3.
So 1
And
upon
why do
area.
we reciprocal this area?
Sorry?
It's
Why
1 by
do
3.
we-
See, it's a, yeah, that is also fine. 1 upon area of D is a formula, but can anyone explain the question asked by him why it is 1 upon area?
Because it is a uniform and the PDF of uniform is 1 upon B minus A. I guess.
No, actually, that
Yeah,
is the
It's equals to 1.
that is the total probability, right? That is the total space. So think now in terms of the dice problem. So what is the probability? Like total is 6, and let's say once we are throwing the die, so one, let's say 1 we get. So what is the probability of that? Something like that, right, ma'am?
Yeah, somewhere. So let's say there are 10 numbers, as the die example is correct actually. So there are 6 numbers, right? When we throw a die, there are 6 possibilities. Okay. So that is nothing but there is a set omega that you can take value, any value, 1, 2, 3, 4, 5, and 6. Out of this value, you can take any value, right? So now if I ask you what is the probability, is you can take any value and uniformly. Then in that case, if you want to calculate what is the probability of getting any single number out of this, then how will you do that? You
1
will
by
just,
6.
yeah, 1 by 6. What is 6? Number of points, right?
Yes, ma'am. Favorable outcome on total
Yeah, you are choosing 1 point out of the
outcome.
all possible outcomes. So how many possible outcomes are there? 6. So similar thing we are using here. Out of this area, you are choosing any 1 point. So there are uncountable points inside this region D, right? And it is given that xy are uniformly distributed over this region D. So what is the probability that you are choosing any particular point? So as it is a continuous random variable, but still it's a joint one, so we can find in somewhat manner. So at a particular point, what is the probability? What is the joint probability that x is taking some particular value and y is taking some particular value? So you will just fix that point upon total area. Fine. So here number of points for your total count. Here what will be your total count? Area. Fine.
Ma'am, the answer, it is given that 2 by 9 x minus 3. How did that x minus 3 come?
So just a minute, wait. This is just a joint density. The question is about marginal density, isn't it?
Oh, okay.
The question is about marginal density. So fx of x, what is the formula for marginal density?
Integrate with the dy.
Integrate.
With respect to dy.
Integrate with respect to dy, but whom to integrate?
0 to infinity.
0 to y minus 3.
0 to?
X minus 3.
X minus 3.
So now, yeah, 0 to x minus 3. Is there any doubt to anyone why we are taking 0 to x minus 3?
No, we need to take the range of y, right? That's why we are taking x minus 3.
Yeah, but range of y is, yeah, from here only x minus 3 you can take it.
X minus 3.
At
Yeah.
some point will be x minus 3 for y.
Sorry,
We'll
what?
take a point in y where the y value will be x minus 3.
What? Like your voice was broken, so can you please
Yeah,
repeat it?
we'll consider a point in y. That point will be x minus 3.
But actually it will be 3 minus x.
3 minus x, yeah.
Yeah.
So the total is 3. So we have 3 minus x will be the value of y.
Yeah.
So we consider that point.
Yes, exactly. So from this only, we decided it's a 3 minus x. Okay. So integrate it. So 2 by 9 is a constant, and 0 to 3 minus x dy. So 2 minus 9 is 2 by 9 is constant, so just keep it outside, and by integrating we'll get y only, 0 to 3 minus x. So your fx is what? 2 by 9 into x,
2 by
3
9
minus x.
Yes, ma'am.
Okay, that's it.
Ma'am,
Yes.
ma'am, which slicing do we do for a marginal of x? Vertical.
For marginal, when we calculate marginal, at that time you do not need this one. What we say, the surface integral will not use here. You can directly integrate it. There is no role of
No,
strip
ma'am,
there
I
when
want
you
to
calculate
understand the
the.
limits.
Yeah, please.
Ma'am, I was asking, when we find marginal of any particular random variable, we do slicing in order to understand the limits.
Yeah.
First, we should integrate it.
Yes. Okay. Okay.
So that in the graph, I was asking, do we do vertical slicing or horizontal slicing for x?
Parallel to y actually.
Then just okay. I'm just asking you to you only how you will find that range. Okay, you are asking me how to take the steps. So you are clear that these are the limits of y only.
Yes, ma'am.
Okay, so I want my limits in terms of y. So if I take, for example, if I take this strip, okay, let's say I am taking horizontal strip, then this will be limits of what? Okay, this is limit 0, and this will be limit what?
This will be 3
This will be a limit of x or y.
This is
X.
this one in particular is 3 minus.
Sorry, what? Particular?
3 minus y.
3 minus y. So you considered it as a limit of x. Why? Because strip is horizontal, so now you can move your strip from down to upward, right?
Yes.
But I want limit in terms of y. Then what should I take? I should take a vertical strip. Okay. So now, yes, to cover my area, and I want limit in terms of y. So I will take a vertical strip. So the limit will be 0 to, yeah, what? 0 to 3 minus x, okay?
Yes, ma'am.
I hope it would be clear.
Yes, ma'am. In uniform, we don't need to do the slicing. That's what. Ma'am, you said that we don't need to do the slicing.
Yeah, because here, see, from this one also you can directly have your limits. X plus y less than 0, less than 3, and y is greater than 0. So you can directly take from here. You will need slicing when considering the area, when you want to calculate the area.
Okay.
Okay.
Yes. Thank you.
Fine. So let's move to the next question. So question number 4. A certain type of thread is manufactured with a mean tensile strength of 40 kg at a standard deviation of 5 kg. If the variance of sample mean for a sample size n1 is 0.0625 and variance of sample mean for a size of n2 is 0.0417, then find the approximate value of n2 minus n1. So yes, how to do this question?
We use the formula of variance for sample mean, sigma square by n.
Okay. So we have given with the mean.
Mu 40.
Mean is 40 and variance
Sigma
is
is 5.
And
Standard deviation is 5. Variance is 25.
yeah, so it's a standard deviation only. It's not variance. See? Sigma.
We can square it, right?
Yeah. So that is variance when we square it. Okay. Okay. One more thing is given that variance of what?
Sample mean.
Sample mean. Variance of
size
sample mean.
N1.
Okay. So just tell me, these are mean and standard deviation of what?
It is of the whole population.
Original distribution. Original
Yes.
distribution.
So we are given with x bar, let's say x bar is sample mean, and there are n1 samples, right? So variance of x bar of n1 will be given as what? Variance
Sigma square by n.
Sigma square n1. That means sigma square, like variance of n1 sample divided by n1, right?
Yes.
Is equal to 0.0625.
That will be what? The sigma square is
0.0625.
25 by n1, right? And this is given, right? What it was? 0.0. Sorry, what?
0.0625.
625 is equal to 25 by n1. So we have n1 from here, right? 625 multiplied by 25. Fine. Similarly, we can have n2. Variance of x bar n2.
Ma'am, divide now.
Ma'am, N1
25 by 0.
there will be 25.
Oh, sorry,
We'll
sorry.
divide it.
Yes. Thanks. It will be 25 upon 0.5. Okay.
No. 0.0625 divide upon 25.
No, what you are saying
It's
correct.
correct, ma'am. It's correct.
Correct.
You will just fix it here, right?
Yes.
Okay. So it is 0.06 or 0.625?
0.0625.
Okay, 0.625. Okay. So the rest of the part is calculation only. Sigma square of n2. Similarly, we can have n2 here. What is variance of x bar? 0.0417. Right, which is equal to 25 by n2. So we have n2 and we have n1. Just subtract it. That's our required solution. Okay. So here we used what? Sample mean formulas to solve this kind of questions. That's it. That was the only logic.
Ma'am, 600 minus 400. N1 will be 400 and N2 will be 600. We got 200.
Okay.
Yes, ma'am.
So like I'm leaving this calculation part. This is just like I have to put these values here, right? That's fine. N2 minus N1, you can just do it, right? So I'm just leaving it. So next question is about. So you might got if it is 600 and 400. So something around like 200, right?
Yes, ma'am.
Yeah, what?
It's approximately 199 point something.
Yeah, that's why in this kind of, if this kind of questions are there where this decimal will create some calculation error, like it just how much like depends on calculator. So we give the range there. So if it is 199 point something, so the range might be given 198 to 202. So that's fine. Any answer lying between them is correct.
200.
Oh. So question number 5. Suppose the moment generating function of the random variable x is this one. Okay, 2 lambda squared. So in the last session we discussed something, right? This kind of MGF is spatial MGF, right?
Yes.
If there are 4
Yes.
IID samples, IID samples with distribution X, and Y is a random variable which is given as sum of random variables. Okay. So, okay. So this question was not visible to you guys, right?
Yeah, it was not visible.
That's all.
Ma'am, here sigma square is 4, na?
Let's take it. How did you calculate 4?
By comparing with the formula of the normal 0 comma sigma square MGF.
Okay, let's take it. Whatever. So MGF is given, and Y is sum of all these 4, and distribution of Y is being asked. So how will you start this question to solve? Right.
You convert this expression e square lambda square into that normal formula. E to power lambda square
Okay.
sigma square by 2. And
Then
then
what?
compare it. And then compare it.
Okay. So one more thing I can do, that is I know MGF, right? And mx of lambda is what? E to the power twice lambda square. So what if I first calculate the MGF for Y? That will be expectation of e to the power what? Lambda Y, right?
We can make this expression e to power 4 by 2 lambda square.
E to the power?
By 2 lambda square.
2
Above
lambda
1. Lambda square 4 by 2. Lambda square sigma square 4 by 2. Lambda square 4 by 2.
4 by 2. Why?
So we will get sigma is 4.
Because
So this is
comparing with the
okay. You are just telling that sigma square is 4 here.
Yes.
Yes, ma'am.
Okay.
Then 4 into 4, 16.
Okay.
0, 16.
So for this x, your sigma square is 4, right? Because we just
Yes,
compared
ma'am.
it with the
Okay.
normal. So this
And
is
rest
the
is IID.
Mm-hmm.
So we can to the power 4.
4 into variance of x.
4 into variance of x.
And
Yeah,
variance
that.
is 4 into 4, 16.
Okay. Yeah. That is also fine. Okay. Yes, that's correct. One more way that was I was introducing is using MGF.
This one how do you
Ma'am.
solve actually? Y lambda square is equal to 4 here.
Yes, ma'am. I'm asking that question, ma'am.
What? Why this one is 4?
Yes, ma'am.
Yeah.
Okay. Let me just clear this. Here only I will again write it. So I just do it. Okay.
Okay, ma'am.
Expectation of e to the power lambda. Just remove it. Okay. So expectation of e power lambda y. How to write y? Y is what? X1 plus x2 plus x3 plus x4, right?
Yes, ma'am.
So it's kind of, can I write it as, so all xi's are independent, right? Independent and identically distributed. So isn't it this one lambda x1 plus lambda x2?
Yes, ma'am.
So if all xi's are independent and identical, then can I write it as expectation of e to the power lambda x whole to the power 4? So I skipped 2 steps here because xi's are
Independent.
IID. So first, since they are identical, so I can write it as expectation of e power lambda x, e to the power lambda x 4 times, right? Because they are identically distributed, right?
Yes, ma'am.
So this step came from identical because they are identical. Now they are independent also, so I can write it as e to the power lambda x. Expectation, I can separate it now, right? Because all are independent, isn't it?
By the expectation theorems, right?
Yes. expectation and independence both. So if your x and y are independent, then what we write as an expectation of x into y?
Ex into Ey.
Yeah, the same thing I have applied here. Okay. So this was the steps I was. Okay, fine. So now you will ask me, you can ask me that if x is a random variable which is independent, then why are you splitting over e power lambda x? Can anyone answer this question? How can we, since xi's are independent and identical, why I am applying the same rule for the e power lambda x1, e power lambda x2 and so on?
Because they are functions.
Because it is a x distribution of x.
No,
Ma'am, because it is a function of random variable.
it is function of x. That's one step, like half answer. Then what?
Identically, ma'am.
No.
So, ma'am, whatever this function of x will be, it will be same for the.
No. You are halfway.
Ma'am. Independent.
No.
Ma'am, can you please repeat the question?
If
Sorry.
x is a random variable, and let's say y is equal to g of x, that means a function of random variable, then can I say y is a random variable?
Yes.
That was the reason. As e power lambda x are function of random variable, so this are also a random variable which are independent and identical. Okay, so that was some extra thing. Okay, so expectation of e power lambda x raised to the power 4, what is expectation? It is given, right?
Ma'am, one doubt here.
Yeah.
So here, why are we not writing as e power 4x lambda, but we are writing e power lambda x whole power 4?
So e power lambda x raised to the power 4, like that?
No, why we are not writing like 4 times x, right? So 4x only will come in power. We'll just add it.
It's a multiplication. No? Okay. In the power, okay, that's also fine. We can write that also, no problem. That is also fine. There is no problem to write that. So mgx of lambda, right? Raised to the power 4. What is that? Something e to the power twice lambda square raised to the power 4. Then or 8 lambda square. This is mgf for y. Now just remember, if x is following normal distribution, let's take it as z, because we are using x and y both here in this particular question. So if z is following normal distribution with mean 0, variance sigma square, then what will be its this one, what we say, moment generating function?
Sigma square by 2.
Ma'am.
E to the power lambda square into sigma square. Yes.
Have lambda to the power 8, it will there. No.
What if I write a raised e to the power a raised to the power b? Can I write it as e to the power ab? Are they same?
This answer is not matching. Actually, the answer is.
Just a minute. We are not reached to answer. Just a minute, hold it, okay? So just let me tell that is it correct?
No.
No, ma'am.
No. Then what should be there?
No, ma'am, it's correct.
Yes, ma'am, it's correct.
It's correct only. So, like, okay. Fine.
Ma'am, it's a to the power b and it's a to e to the power a to the power b.
So,
Ma'am, it is correct only for e to the power a whole power b.
Yeah.
Okay. Fine. So we have these things here, right? E to the power a whole to the power b.
Yes,
Then
ma'am. It is correct.
Yeah. Yeah, correct. So we use that stuff here only. Okay. So once we have lambda square sigma square by 2, and here if I compare with this y we have lambda square, and sigma square by 2 is what for y?
Sigma square by 2 is equal to 8.
Yeah, that means sigma square is 16. Okay, that implies y is following a normal distribution with mean 0 and sigma square 16. Okay, so that is the answer. Okay, now someone has answered this question in a way which was also easy way.
Ma'am,
So
just last question. You are comparing this lambda square sigma square by 2 is equal to 8 lambda square, right?
yes.
Okay.
Yes. So in the question, see, this was one of the method where you are calculating MGF of y. Another thing you can do is, given that x is following what distribution, I think it was not given, right? MGF of x is given. What was it? Mx of lambda was given as e to the power 2 lambda square, right? So can you just tell me quickly what is the sigma square here? See, x is following normal distribution. How did I get to know that it's a normal distribution? Because the MGF is similar to e to the power lambda square sigma square by 2, right? So here sigma square by 2 is 2. That implies my sigma square is 4. Okay. So now I have 4 random variables x1, x2, x3 and x4. I want to calculate the distribution for y, which is nothing but the sum of random variables. So do you remember that if x is a random variable which is normally distributed, then sum of the random variable will be, that means function of normal is normal, right?
Ma'am, sigma square is equal to 2, na?
Sigma square by 2 is equal to 2. What does it mean that sigma square is equal to 4?
Okay. Okay.
Okay. So y is this one. Then what will be the sigma square? That means variance of y. Sigma square y will be what? Can I write it as 4 times sigma square x?
Yes, ma'am.
Okay, that's it. So here 4 into 4, nothing but 16. Okay. So this was short one. Okay. So let's.
You know, instead of x1 plus 2x4, if we have x5, then it will be 5 times.
Yes.
5 times of 4, so 20.
Yeah.
Okay. Thank you.
So instead of one more thing, let me just check. Okay. Instead of this one, if I change a question, I'm not changing it. I'm just taking the new random variable. Z is equal to x1 plus 5 times x2. Then what is the variance of z then? The rest of the things are same. Similarly, y was a function of x. Now I am taking z is a function of x.
Variance of x1 plus 25 times variance of x2.
Yeah, but just let me tell one more thing. If you are taking the variance of x1 plus 25 times variance of x2, is it possible to separate it?
It is possible, but they should be independent.
So you know the question, right? So were they given independent?
Yes, ma'am.
Yes, they are given independent. That's why we are able to do this. Here also, they are independent. That's why it's a 4 times sigma square. Okay. Otherwise, it will not separate over addition. That's it. Sigma variance of xi is given to us, right? 4. So it's a 26 times 4. That's it. Okay.
Ma'am, can I ask one question, a general question?
Yeah. Go ahead.
Just scroll up a little bit. Yeah, okay. Here y is equal to x1 plus x2 plus x3 plus x4. So since all are identical, so we can write as y is equal to 4 times x.
Yes.
And ma'am, if after that we apply variance of y is equal to variance of 4 times x, then will it be 16 times of variance of x?
Okay. If it is 4x, as they are IIDs. So if
Yeah.
I take
Then variance of y, if we apply variance on both the sides, then will it be 16 times of variance of x?
yeah, it seems so.
Okay.
But with independent and identical distributed, yeah.
Okay.
Variance of x is 4. And according to the rule, yeah, it should be 4 square 16 times. So just be careful, yeah. Good observation. Okay. As they are identical, we can write it. But just a minute, no, we can't. You know why?
No, then it will be
Anyone
64.
can tell me why it is 4x? I can't write it 4x. Why?
Yes, ma'am.
Yeah, that is true. But now just tell me why. This is not.
Because variance of y
Or
is
xi.
variance of x plus y plus x1 plus x2 plus x3 plus x4.
No. The reason will be not revolve around variance.
Ma'am, because
That's
everything will give a different, every random variable will have a different answer.
different answer means?
Different sample mean.
They will not pick the same value every random
Yes,
variable.
exactly. So the person who asked the question, can we write it 4x? So see, these are the random variables which are identically distributed, but still we can't take it as a 4x. Why? Because at a particular moment, when experiment was going on, then it is possible that x1 is taking value 1, let's say, x2 is taking value 2, and x3 is taking value something else, 1 again, or 11, let's say. X4 is taking value 15. So for this particular sampling, my x1 plus x2 plus x3 plus x4 is not equal to 4x, right? It's not 4 times any x.
Yes.
So that is the reason we can't take it as a 4x.
Yeah, because each sample has a different order and the result may be different.
Yes.
So ma'am, so this logic should be applied above also, where you did the same thing, where you took all the random variables as x only.
Where? Oh, hey, here momentum.
Yeah. Here you take everything as x only, right?
Yeah. Yes. E power lambda x1. So, how our moment generating function will look like? See, moment generating function, we generally, when we write a moment generating function, it will be something in a series or something like that, right? But yes, if I put some particular value there, then it is wrong. Rest, I don't think so it will create problem because it's a function, no? As we are not putting any particular value here, but still, yes, we should not do that.
Ma'am, they will follow the same expectation, na?
Yeah,
That's why
expectation will be same.
Same for all now.
Yeah, whatever the values are, yeah, because it's a generalized function.
That's why we are taking.
And also there is one thing, that is moment generating function of this random variable, which is normal distribution. This function do not have x. This is not a function of x. In short, I want to tell them. Are you getting my point? it is not a function of x. It is function of lambda, and lambda is constant for all. Are you getting it?
Yes.
For example, if I say you fx is, let's say, f of x is 3x, then does it matter when I change my x value? If I change x, value of 3x will change, right?
Yes.
But if I define my function as f of x is equal to, let's say, 3, then even though I change x, the value of f of x will not change, right?
Yeah.
It will remain 3 forever. Why? Because this is function of x, which is constant here, or let's say 3y. Even though if I put 3y, I will change x, the function will remain 3y as it is, right? Why?
Yes.
Because it is not actually a function of, it is not including the term x. So it will not affect. The values of x will not affect f of x until unless you change your y. So same thing in the moment generating function in this particular one. So yeah.
Yes, ma'am, understood.
Okay.
Excuse me, ma'am. How it is 26x4? Variable is set equal to?
Okay. Variance of x is what? Variance of
Yes.
x1 and variance of x3 is same, isn't it?
Yes.
Why it is? Sorry, 26 into 4, it was correct. Yeah. Because variance of x1
It's
and
into
variance of
4.
x3 is
Okay.
variance of x only, right?
Okay.
So that's why I took it as a. Is it fine if I write now? Variance of
Okay.
x, variance of x. So yeah. So that's why 25 plus 1, 26. Okay.
Okay. Thank you.
Fine. Okay. Any other doubts?
Yeah, I have one doubt. Can't
Yeah.
we use CLT to approximate its normal distribution on general query?
What?
Can't we use CLT?
CLT.
Yeah.
Um.
Because it also has some similar expressions like y equal to x1 plus x2 and so on.
Okay. How will you apply the CLT here?
I'm a little bit confused, so
No,
could you
no, no.
please?
Your question is okay. That's not a problem. But just understand where to use CLT.
We use CLT to approximate distribution from some given instances or observations.
Yeah, right. But
Yeah.
what we have asked here, the distribution of y.
Yeah.
To find the distribution of y, this will not work, right?
Okay.
CLT will give you the probability that how much your actual mean is away from your, how much sample mean is away from your actual mean, isn't it?
Yeah.
So
Okay.
here we are dealing with the PDF of a function, so no need.
Okay, ma'am. Thank you.
So should we move to next one?
Yes, ma'am. Only 50 minutes are left.
Yes, ma'am.
Yeah.
Maths 2 session are also there on it.
Okay. So next question is probability mass function. Okay, is it visible? Yeah. So probability mass function of a random variable is given like this, and find the value of k. So isn't it super easy question?
Yes, ma'am.
How to do that?
Just add all the
to
values,
one
When you add
equal to
everything,
1
it will give
and
1.
equate to 1.
Yeah.
and
So
leave this
summation
question.
of, yeah. Okay, fine. So what was your k value?
0.25.
Yeah. So I'm just writing as summation of all the pxi's should be equal to 1, and we have to just solve a quadratic equation and we'll get k is equal to 0.25. Fine. What about the next one?
Ma'am, can you please tell? We have to equate everything, add
Okay.
everything and one. Okay. Okay.
Yeah. So will not take much time. Okay, let me just show you. What are the values? K plus what?
K plus
3k plus 4k
2k
square.
plus k square plus k square plus 2k square.
Yeah. Plus 2k square is equal to 1. So this is
1.
nothing but 4k square plus 3k minus 1. A quadratic equation.
Yes,
And
ma'am.
just find the value of k using that formula method.
-1 1
And
by
we
4.
get k as
Quadratic
equal to,
formula.
yeah, k will be 1 by 4.
Ma'am,
And
leave
minus
it.
1.
Yeah. So negative one when we will
We won't take. We
not
won't.
take. Why we cannot take? Because k is the probability that x is taking some value 1, and probability cannot be negative. So we'll avoid that value and we'll take this one as a 0.25. Okay. So next one is what? Question number 7 is about
Conditional question.
yeah, conditional probability. How to get the conditional probability? Let me just check the question. So probability that x is lying between 1 to 4 given that x is greater than 2. Okay.
We write this expression as probability of x in between 1 to 4 intersection of x greater than 2 upon probability of x greater than 2. And it solve the equation.
Okay. So probability that x is lying between 1 to 4 given that x is greater than 2. So this is nothing but probability. Yeah, it's the
X is
conditional
equal to
probability.
3.
So intersection, yeah. X less than 4 and x greater than 2. Probability x greater than 2. So for x lying between 1 to 4 and x greater than 2. So what are the possible values? 1 to 4, it should be greater than 2. That means probability should be start from 2 to less than 4. That is nothing but probability 3. What about x greater than 2? It's nothing but the probability that x is 3,
3 f
4,
plus 4.
and 5.
Yes.
And this one is probability of x is equal to 3.
Yes, ma'am.
Yeah. Then how will you work with that?
From the PMF table.
Yeah, k
PMF.
square upon k square plus 2k square. So nothing but 1 by 4. Okay. Fine.
Yes, ma'am.
Okay. Then next. Let x is a uniform random variable in the range 0 to 5 and g of x is x minus 2 the whole square. Define a new random variable y is equal to g of x. Find the CDF of y. So this kind of question we have done, right? In
Yes, ma'am. Use the formula monotonic PMF PDF.
Can you use monotonic formula here?
No.
I guess no.
Can't. You can't.
No,
Why?
because not monotonic in the range.
Yeah, it is up and down, is it?
So this kind of
Given
question
range.
we have discussed. Anyone remember that if it is a uniform in the range 0 to 5 and what g of x is x minus 2 the whole square. Anyone have solved this question? Yeah, when you
First we find the PDF of the uniform, means 1 upon 5 will be the PDF.
yeah. So let's say somewhere to here. So can anyone just tell me what will be the range of this g of x? That is nothing but y.
0 to 9.
4 to 9.
0 to 9, actually.
It's 0 to
Y
9.
is equal to x minus 2
Yes,
the
ma'am,
whole
0
square.
to
Yeah,
9.
what is
Yes,
0
ma'am.
to
9.
9? 0 to 9. Okay. So the graph will be something like this one. Somewhere here 4 will be there, right?
Yes.
So this should be 4 actually.
Yeah, that's what it should be for. Yeah.
Okay. So y is ranging between 0 to 9. Now, then till this point, that means point 4. Something symmetricity is there. That means whenever your x will range between 0 to 2, in that case, or actually 0 to 4, right? Whenever your x is belonging to 0 to 4, your y will take values between, yes, what? 0 to
4.
4. And when your x will be lying between 4 to 5, in that case, your y will go to
4 to 9.
4 to 9.
Okay. So that's why we have to calculate this in two ways, like in two different manners. So let's take x is lying between 0 to 4. And one more thing, yeah, PDF of x. What
Ma'am,
will be
how
the
you
PDF?
slice range of x, ma'am? 0 to 4, 4 to 5, ma'am.
Using this. So just take your x is taking value 0 to 5 and y is nothing but x minus 2 the whole square. So just check what are the values it will going to take. And symmetricity, we are just first deal with the symmetricity and then take the rest of the part. Right?
Yes, ma'am.
So let's take x is equal to 0, it will give you minus 2 square. X is 4, then 4 minus 2, 2 square. So 0 to 4, it will lie between 0 to like this range. Okay.
Okay.
Fx of x is what? X is a uniform distribution, so PDF will be 1 by 5, right?
Did we write the x value correctly? I mean, is it because it is the vertex is at 2, so this side 2, that side 2, 4, 0 to 4. Okay, yeah, fine.
That's just a scaling part. No? Like
No, fine. I got confused because 0 to 2 is 2, and after that 2 is there, which is taking to till 4, and 4 to 5 is taking to 4 to 9. Yeah, correct.
Yeah. Okay. So fx of x. Now, how to do that?
U minus a by 2, right?
What?
PDF formula is b minus a by 2.
B minus
1 upon b minus
no, b minus a by 2 is the expectation formula. We are sorry, even though it's a plus b. See, PDF is 1 upon b minus a for uniform
Yes,
distribution. So yeah, how to go with that? Now x is ranging between 0 to 4 and y in that case will range between 0 to 4. So how to start with that? Is it fine if we write like that? X minus 2 the whole square, right? So in terms of x, if I want to calculate it, what it will be? Probability x minus 2 is ranging between plus or minus square root y. Is it fine? Or I can write it as what? Minus square root y to x minus 2 to y. Square root y, right?
Yes,
ma'am.
Minus square root y plus 2 to, so x is ranging between this one. So I think you guys are able to calculate this after that. So just integrate it.
You can solve it, ma'am. You can solve, ma'am. Whole, ma'am.
Minus square root y plus 2 to square root y plus 2. What is fx of x? It's 1 by 5, right?
Yes, ma'am.
Yes.
So just put your values minus square root y plus 2 to square root y plus 2 and 1 by 5 dx. So that is nothing but 1 by 5 and x. So okay, I'm just directly putting the values. Okay, it's just 1 by 5 x, and I will put the limits square root y plus 2 minus of square root y plus 2, right? So this 2 will get cancelled, and this is nothing but 2 by 5 square root y. For what values? 0 to
0
4.
to 4.
Okay, this is CDF of y at this particular 0 for y ranging between 0 to 4. Now, for the values, when y will start taking values y 0 to 9, what will be my x values? 4 to 5, right?
Yes, ma'am.
Then after that, my CDF will look like, okay, Fy of y is what? Probability y less or equal to small y. Then x minus 2 the whole square less or equal to y. Fine. So now my x values are 4 to 5 and I am calculating CDF of the functions. So what will be the changes here? Yeah, anyone?
Function will remain same, the limits will change.
So just limit we will change and replace.
Yeah, that's it. The limit will not take that negative part because no need now, because symmetricity is removed. Because for this portion, when x is taking values, see, after this point, graph is not symmetric, so no need to take the integration over another negative side, okay? So that's why it will be the integration from...
Ma'am, it will be root y plus 2.
Yeah, it's a plus 2. Square root y plus 2, 1 by 5 dx, right? And that will be nothing but square root y plus 2 divided by 5. So that's our CDF for y ranging between 4 to 9. So in final, if we write as a CDF of y, it will be 2 square root y by 5 whenever y is ranging between 0 to 4. Right? And it will be 2 plus square root y divided by 5 when y is lying between 4 to 9.
Ma'am, I don't understand why did we take only positive side?
Because whenever x, and this is x is equal to 4, okay? So whenever x will start increasing 4 to 5, our graph is not symmetric now. So no need to take this negative portion. So that's why we removed it.
Madam,
Okay.
can you, thank you, madam. I lost the when you calculated 1 by 5. How you got 1 by 5?
So your x is a uniform distribution for the interval 0 to 5. If x is uniform distribution, how to get PDF? It's nothing but 1 upon b minus a.
Yes, yes. So it
B
is
is 5a.
it will be same for both the limits because we have two limits of x 0 to 4 and 4 to 5. We have 0 to 4 also 1 by b minus a.
No. Your x is a uniform. We are separating it because of the nature of y. Because of the nature of this function. Otherwise, there is no need to separate it.
Okay.
So the PDF of x will remain 1 by 5 only because it's uniformly distributed between 0 to 5.
Okay, PDF.
Ma'am, please show the first part of integration.
Okay.
Ma'am, can we get this PDF after the class?
Yeah, sure.
Okay,
This
thank
is
you.
first part of integration. Okay. If you guys are writing it, then no need to because I will share it.
No, ma'am, this is an important question, so it will be good if we all will understand.
Yeah. So this
And just
question we have
to just
also discussed in one of the open session. I do not remember that it's week 6 or week 7. The similar question, just instead
5,
of
ma'am.
x minus 2, it was y is equal to x square and the x was lying between some minus 3 to 2. As much as I remember, it is like that.
minus 3 to 1.
Yeah, minus 3 to 1. Yeah, similar.
Ma'am,
Yes.
ma'am, I think people can refer the live session recording.
What?
Ma'am, I think we can refer the live session recording afterwards to go back.
Yeah. That's why I'm telling that only, that this kind of question we have discussed in that open session also. It's available on YouTube. You can go and check that.
Ma'am, question 9 is easy, but it's very simple. Integrate in the given
Yeah.
range of the
There is
function.
no need to integrate even. See, this question number 9 is actually super easy. It's asking about probability that y is ranging between 1 to 6.25. What will be your action to solve this question?
f of a minus f of b, and we know that both the values.
Yes, ma'am. Then you use the formula of CDF of uniform. x minus a upon b minus a.
That's it. Yeah, no need to integrate it. So it's a probability that y is ranging between 1 to 6.25, right?
Yes,
So
ma'am.
this is nothing but fy of
Probability of
6.25 minus
fy of 1.
fy of 1. So from this fy, we can find what are these values, right? Fy of 6.25, what it will be? 2 plus
X
square root y, that means 6.25 upon 5 minus
Yes,
fy
5.
of 1. Fy of 1 is in this one, 2 square root y, 2 square root y by 5. So this 2 by 5 will cancel, and we will remain with the square root 6.25, right? Okay. 2 by 5 plus square root 6.25 is what? Nothing but the 2.5.
2.5.
2.5, yeah. 2.5 upon 5 minus 2 by 5, right? So this both get cancelled, and yeah. This will be 1 by 2, right?
Yes.
So 0.25, 0.51. So this is your solution for this particular question.
Ma'am,
Yeah.
can you summarize the previous question with measure steps method?
Yeah, sure.
Okay.
So see, x was given as uniform distribution from 0 to 5, and there is another function g of x, x minus 2 the whole square. So I just wrote y is equal to g of x. Okay, you can take it as y is equal to g of x minus 2 square. So whenever x is uniform distribution, first step is just write its PDF. Its PDF will be 1 by 5 for the range x lying between 0 to 5, 1 upon b minus a. Okay. Now,
It's PDF, ma'am.
yeah, it's a PDF.
Okay.
So x minus 2 square, the better is to just draw the graph. The graph will be look like this. And from here, you can see that there is a symmetricity till the point y is achieving 4, right? So we will just separate or take the two parts of this x. The one is symmetric and one is rest of the portion. So whenever x was lying between 0 to 4, your y was lying between 0 to 4. And for rest of it was 4 to 9. So just take one portion for symmetricity. When your function is symmetric, that means this part. By symmetric, do you understand symmetricity? The graph
Yes, ma'am. Yes.
on the left and right two is
Are
same.
equal, same, ma'am.
Yeah. So in that case, in such a case, when we take square root on y, then we have to consider both the portion, left one and right one both. So that's why when I squared it, I considered this negative portion and positive both, and then converted all the stuffs in terms of x. Then I know that distribution for x. That means PDF of x we know. So we will just use our formula. Using PDF, we will calculate the CDF of y like this. Okay. So just calculated CDF when y was ranging between 0 to 4, so x was 0 to 4. Now for the next portion, when y is 4 to 9 and the portion is not symmetric now. So in that case, I will not take negative portion and just integrate it from 0 only, right? 0 to square root y by y plus 2. That's we integrated, and that's all. Okay.
Ma'am.
Yes, ma'am, got it.
Okay.
Yeah. In one of the cases, in the first cases, once we have taken the range from 0.
In what one?
That range is covered, ma'am, on integration. Then why we are again taking from
But
0
it's
to
a
0?
CDF, no? So it's a CDF. It's a cumulative distribution function. So we will cover from 0 only.
For the range of x from 4 to 5. The symmetric part for the y range we have already taken from 0 to we cover all this. from root over minus root over y to y.
Yeah. Do you remember the CD? Let's say whenever we calculate CDF, then its graph will always look like something like that. Do you remember that? Why it is so? Because at this particular point, let's say this is some point alpha. When we find the CDF of CDF at a point alpha, that means we calculate probabilities of all the x which are less or equal to alpha. So cumulative distribution function, it takes
Yes,
all
ma'am.
the previous probabilities and add it. So that's why we integrated. We started our integration from 0 itself,
Okay, okay. Got
not
it.
from 4. It's a cumulative one, so we will not just integrate on that particular area. I was expecting this question actually. That's good.
Got it, ma'am. Thank you.
Yeah. So let's move to next one. Question number 10. Okay, this kind of question also we have discussed. The joint density of two continuous random variable x and y is given to you. Are x and y independent? How to do that? Do you remember?
Find the marginal of
Find
both
fx and fy.
Yeah.
Multiply them.
Yeah.
If joint is equal to product of their marginal, then it is independent.
Yeah. So this kind of question actually are easy. Whenever you see this kind of question, just solve it quickly. Time saving questions. Yeah.
Sorry, ma'am.
What?
Ma'am, I didn't understand the limit, ma'am.
Which limit?
In previous question, ma'am.
Okay.
Last limit, ma'am.
Yeah, yes, it's just a minute. I am just completing it. This one?
No, ma'am. No, ma'am. It's previous question. Yeah.
This limit part?
Second limit part, ma'am.
Second limit part. Okay. So for that, okay, I'm just again I'm trying. See, in the second part, whenever your x is ranging between 4 to 5, your graph here is not symmetric. Now it's
Yes, ma'am.
this right portion only we are considering, right? That's why we will take the limits from 0 itself, not from the negative square root y. Still, if you have a doubt, then I think week 5 someone told, right? We have discussed the similar question. Just the difference is -2 was not there, but the concept is same. We have discussed there in detail. So
The
please check
discussion
it.
is with mod x, I think. Mod of x.
Sorry, what? Yes.
Mod
No,
of
no,
x,
no,
yeah.
no, no. It was same. Y is equal to x square with the
It was the
limit.
same question and it was in the lecture as well. In lecture 5.1, the question is there. It is briefly explained by professor.
Yeah. It is x is ranging between -3 to 1 and your y is equal to x square. The same question sir has discussed in the lecture, and we also have discussed twice in a lecture in
Okay,
previous
ma'am.
lectures.
Okay, ma'am.
So just please take it.
Okay, ma'am.
Okay. So to check whether x and y are independent or not here, the first task is to check whether your marginal densities, product of marginal density is giving you your like joint density or not. So how to check marginal density here? Fx of x, yeah.
To y for getting marginal of x.
So what will be the limits of y then?
0 to
0 to
infinity.
infinity.
0 to infinity, okay. So just integrate it. E to the power minus x plus minus x plus y dy. Integration with respect to y, that means x is constant, right?
We can
So,
split the term.
It go y.
Minus y upon minus 1 and integrate from 0 to infinity. What is e to the power minus infinity?
0.
Okay, so it will be 0 minus e to the power 0 is 1, right? So it's
Yes.
nothing but e power minus x. Similarly, if you do your fy of y will nothing but the e to the power minus y. So from here we can say that our x and y is independent, right?
Yes, ma'am.
Why we can say that? Because our fxy
If we
is
multiply, we
e to the
get
power minus x into e to the power minus y. Yeah, it's nothing but the marginal product of the marginals. So independent, okay? Okay. So let's see what is the next one. Yeah, find the value of probability x less than y. So I am just giving you 1 minute as we discussed a similar question in last session also. So how to how to calculate that probability x less than y? Keep your mic unmute if you are not speaking.
X is equal to y line and then.
Yeah, just integrate it.
Is this question related to our one?
Yes. The previous one, question number 10.
It was not clear.
What? We have to calculate probability that x is less than y. Now you have joint density, right? Joint density of x and y is given to you. And the limits of x and y is given to you. So just in the first quadrant, just draw x less than y, where it is, identify that, and just take the strip whatever you want and integrate it. That's it.
Ma'am, in the integral, the limit will be from 0 to y, right?
Just check it. Will it be 0 to y? It depends, like how you are taking your strips.
Ma'am, are you there?
Yeah, done.
Yes, ma'am.
Okay. So how we'll do it? So our function is like our PDF is even the e power minus x plus y. It will not affect that much because we know that the range for x will be 0 to infinity, y will be 0 to infinity, right? So just whatever the graph is in this whole first quadrant, right?
Yes.
So just x is equal to y, draw it. So you know the exponential graph, right? -1. It lie on the first first two quadrants, but we are interested in this order. Yeah. Then now x is greater than 0, y is greater than 0. This is x is equal to y. We are interested in probability x less than y. Yeah. Which one? Upper one, lower one?
Upper one.
Upper one, ma'am. Upper one.
Okay. This is our.
Is this question related to 10th question?
Your voice is not clear. Can you speak loudly?
Ma'am, is this question related to the previous question?
Yes.
Ma'am, but it is not mentioned anywhere.
Okay. But it is.
Okay.
Okay.
Below the line will be the given region.
Above the line, not below the line. X is less than y, no?
Yes, ma'am, it's important. Yes, y
X
is
is less
greater
than
than.
y, so this part is your origin. Now, which step do you want to take? Horizontal or vertical?
Horizontal.
Okay, why?
It's easier, ma'am. 0 to y. will be
Okay.
the-
Both are equivalent, like whatever you want. That's easy on it. Okay, fine. So this will be the limit of what?
Or we can also calculate the area.
Yeah, but how will you calculate the area? Because for area, you want base into height, right? How will you calculate the base?
Yes, ma'am.
It's a 0 to infinity, no?
Yes, ma'am.
So integration is the only way here. So, okay, you took the horizontal strip, then these are the limits of what? What will be the limits of x? What will be the limits of y?
Ma'am, here also, we will also draw the graph of e raised to the power minus x plus y.
Yeah.
In the first quadrant.
Yeah. The graph will be of this x distribution of x and y, right?
Yes.
So we are like exponential graph will lie here in the whole first quadrant. So we are not drawing our graph, okay? But we are interested in this part, this area of our region. Fine.
Yes, ma'am.
Okay. So fxy dx dy or dy dx. What do you want to
dx
take?
dy, ma'am.
Dx dy.
Outer integral 0 to infinity.
That is the limits of
y.
Okay, 0 to infinity. And what about x?
0 to
0
y.
to y.
0 to y. Okay, very good. So now just the part is to solve it, right? So 0 to infinity integral 0 to y and what? E power minus x minus y dx dy. So first with respect to x, so exponential y is constant. 0 to infinity e power minus y minus 1, 0 to y dy. Fine. And that will be integral 0 to infinity minus y constant. Let's take minus 1 also. So it will be e power what? Minus y minus a to the power 0, that is 1 dy. And then minus minus plus. So e to the power minus 1 minus y and minus e to the power minus twice y. Okay. Is it okay if I switch the terms? Or if it's confusing?
No, correct, ma'am.
Yeah,
Yes, ma'am,
I have
correct.
just switched the terms. That's it. To just take minus consideration. Okay. 0 to infinity. Okay, just directly integrate it. E to the power minus y by minus 1. And this will be plus e to the power minus 2y divided by 2. Okay. Or just take it as like this. No problem. Okay. So the limits are again from 0 to infinity. So if someone is like confused with this negative and positive sign, then better safer side is just to keep out, like first take your positive sign. So this will be a positive part. So just take it e power minus twice y by 2 minus e power minus y integral 0 to infinity. Now just put infinity. So it's the negative part, right? E power negative infinity is 0, isn't it? For whole term. And 0 minus e to the power minus 2 into 0 divided by 2 minus e power minus, sorry. So just directly can put it as a 0, no problem. Yeah, so e power 0, 1. So this is nothing but negative 1 by 2 plus 1. That is equal to 1 by 2. Okay. Done. So this is probability that x is less than y. Okay. Any doubt?
No, ma'am.
Okay. Yeah.
We do not have to divide this by whole probability.
By whole probability. No, no need to. Why?
Required area upon total area, we do not have to.
No. Because this thing will be there when there is something kind of non-uniform distribution, or that you don't, the distribution you don't know.
Because, ma'am, the area we want, the probability of x less than y, will be the intersection of e to the power minus x plus y.
Minus
so it
x
should
plus
be
y.
Intersection of the graph divided by the whole e to the power minus x plus y.
Intersection of graph with the e to the power minus x minus y.
This probability what we are calculating, this area should intersect with e to the power minus x plus y divided by the area of e to the power minus x plus y.
No, that's a different thing. You are like mixing it. But see, whenever there is some function that we know that it's lying in the first quadrant, like this. Okay, this is our PDF, and we know that x is greater less than y with range here, and we know that this graph will be somewhat like this, right? So we are actually calculating the probabilities whenever this event is going to happen, and all the points where x is less than y.
Okay. That was in the case, ma'am, when PDF was not given.
Yeah, PDF was not given. Here
Here
PDF
we are
was
giving
given.
the PDF and only we are calculating the range.
Yeah, exactly. Okay, so yeah, question number 12. So there are x1 to xn IID samples exponential distribution with lambda is equal to 1 by 3, and x bar is your mean. Which of the following inequalities are true with respect to Chebyshev inequality? Okay, to solve this kind of question, what is our first task? What should be our first task?
Calculate the mu and sigma square.
Okay, so what is mu here? What is sigma here?
Mu is 3, sigma square is 9.
Okay. So xi's are following what? Exponential distribution 1 by 3. How did you get to know that your mu is 3?
1 by lambda.
Like 1 by lambda.
Yeah. So nu is equal to 1 by lambda, and lambda is equal to 1 by 3 in this particular case. So that is okay. How did you get the sigma?
Same.
1 by
lambda square.
1 by lambda square.
Okay, yeah, fine. So nu is equal to 3 here in this particular case. Okay, nu 3, sigma 3. Then what is your next step?
Write the Chebyshev inequality.
Yeah, what is that?
Ma'am, we can use law of large number also.
But we have to use this inequality, right?
Yeah.
According to the question, we can get the answer from the law of large number also. So yeah, which form you will use? Is it fine if I use this modulus x bar minus nu greater or equal to k sigma?
Yes.
Yeah.
Which is less or equal to 1 upon k square, right? So we were finding which of the following is correct, right? What is question here? Yeah. So it is 0.25 and 0.5. Okay. Probability that modulus x bar minus nu greater or equal to 0.25 is what? So they are mainly discussing 0.25 and what 0.3, 0.5, right? Isn't it? In the question, they are asking this k sigma about this 0.25 and for x bar minus 3 greater or equal to 0.5. Isn't it the question? Yeah. About these two things. So let's.
Question we are taking this and substituting and finding that. Is
Yeah.
Okay.
So if I want to find the probability that x bar minus 3 greater or equal to 0.25, how will I work? So isn't it my k sigma? Okay. So this is about x bar. If I know the distribution mean and variance for x, what will be the mean and variance of my x bar?
Mean
X
will
bar will be mu.
and variance will be sigma square by n.
Okay,
Yeah.
so may I write it as an expectation of x bar? Is it fine?
Yes.
Yes.
So
ma'am.
that will be 3, right?
Yes.
And what about sigma square x bar or sigma x bar?
Sigma square by n.
n. Okay, but we need sigma x bar only, right?
Yes.
So that will be 3 by square root n. Fine. The square root of this one.
Yes.
Okay. Yeah, sigma x bar will be sigma upon square root n. Fine. Then, okay. So probability that my x bar minus 3 is greater or equal to, let's say, some k sigma. Okay. I will just find in a generalized way. Is it fine if I start like that?
Yes.
So my first I want my k sigma to be equal to
0.25.
0.25, right?
0.25. Yeah.
Yeah. So sigma x bar, or you can just write it as a sigma by square root n, whatever you are comfortable with. Okay. Are they same?
Yes.
Okay. So k sigma
Weak
by
law
square.
of large number.
Yeah. What?
Weak law of large number.
Yeah. Weak law. Why it's weak law of large number? That implies what is the value of k here?
Yes.
In terms of n only we will get. All the options are in terms of n, no problem. Okay. So it will be 0.25 times n divided by square root n divided by sigma. What is sigma there? 3. So what will be k square? If k sigma by square root n is 0.25, then my k square will be 0.0625, the square of 0.25 multiplied by n divided by 3 square, that is 9. Okay, 9. Okay, what will we get once we solve it?
144 n.
144. Okay, okay. N by 144, right? Isn't it? So that means 1 by k square will be 145 by n. Any doubt here? I think that's going wrong.
Why did we take this 0.25 divided by root n? I mean, it is asking. Yeah, that see, first it was 0.25, right? Then we divided by root n. Is it like the first one is for population and later we made it for the sample? See here, mod of x bar minus 3 greater than or equal to 0.25.
Yeah.
I mean, little. I
Yes.
think,
Yes.
yeah.
Greater or less or equal to both.
So why we are dividing that by root n?
Okay. So what is our this Chebyshev inequality? It says that it is a modulus of x bar minus nu greater or equal to k sigma. This is the sample mean, right? Sample variance, sample mean. So what is sample mean? We calculated it here. Sample mean is sigma square root n. So that's why I put it here, sigma square root n.
Okay.
This is sample mean. When you use this Chebyshev inequality, this sigma is sample mean.
Sample mean and sample variance.
Yeah, sample mean. Oh, sorry. Yeah, sample variance. Sample mean and sample variance.
Ma'am, one more thing. In weak law of large numbers, sigma square by n delta square, that sigma is a population mean, population variance.
That sigma is, yeah. Yes. In weak law of large number, we use that.
Okay, that is population variance.
Yeah. So 1 by k square is 144 by n. That means which inequality is correct? Modulus x bar minus 3. What? Less. Which one? Greater or equal to or less or equal to? This calculate greater or equal to, right?
Greater or equal to.
Greater or equal to 0.25 is less or equal to 144 by n, right? That so out of this option number, which options are there?
First one.
Yeah, but we have to check for another option also where they have used 0.5 instead of 0.24. So out of this option number 1 and 4, option number 1 is correct, right? Now let's check for the another option 0.5. Okay. Are you getting my point?
Yes.
Yeah.
What because it's a multiple collective. That's right.
Ma'am, when does it become 1 minus the probability?
Yeah. So just okay, you want to see when does it becomes 1 minus. So let's take x bar minus 3 less or equal to 0.5. Then it will become what? Do anyone want to answer it?
Ma'am, take
Greater than or equal to 1 minus 1 upon k square.
1 minus the
1 upon k square.
1 upon k square. Okay. Let's say this is our what? K sigma. So instead of k sigma, we will write k sigma by square root n, right? Why? Sample variance. Okay. So k sigma by square root n is what now? 0.5. Okay. Is it okay?
So, ma'am, generally, if we change the inside sign, the outside sign also changes, and we put -1 there.
Yeah. Like in general format, it is like that. In general format, it is.
Yes, ma'am, I'm asking.
See. If probability that x bar minus 3 is greater than 0.25 is this one, then once I change, reverse the sign here, what does it imply? What will be that probability? Out of total probability, subtract this one, right? That's what we are doing. Okay.
So
Yes.
basically, it's the complement.
Yeah, it's a complement. Because the sum of all the probability that has to be equal to 1, right?
Yes.
I got it.
Okay. So when k sigma upon square root n is 0.5, what will be the value of k then? So that we have to square it. 0.5 into square root n upon sigma, right? And k square will be nothing but 0.25 n divided by what is sigma square 3. Is it fine? So if it is 0.25 n by 3, then is there any options related to that? What will it be? 0.25 upon 3?
That we have to take 1 minus. Okay.
Yeah, 1 minus or whatever. So rest of the part is just a calculation part, or it should be 9, no? If we are squaring, then this will be 9, right?
Yes, ma'am.
Yeah, okay. So 0.
No, ma'am, there's no such option.
Yeah, what? There is?
There is no such option.
But we want 1 upon k square, so that will be 9 upon 0.25 n, isn't it? And now you just divide 9 with 0.25, we'll get some 36, right?
Yes.
36 upon n. So this will be my 1 by k square. So what is the probability that x bar minus 3 is less or equal to 0.5? Will be what? Less or equal
Greater
to
than or equal to. Greater than or equal to.
Just take it, okay? Yeah, it will be greater or equal to 5.
Minus 36 by n.
Yeah, that's it. Is there any such a option?
Yes, ma'am.
So yeah, the option number 3. Okay, that's how we use this Chebyshev inequality. Okay. these inequalities have their own significance, so be clear with these concepts. Okay, so question number 13 is find the minimum value.
Ma'am, sorry, ma'am. Ma'am, can you write just the formula for using that weak law, ma'am? The same.
Weak law of large number, that delta.
Yes, delta, ma'am.
What is
Just
that?
the formula.
Okay, do you remember
Because I
what's the
saw.
formula?
Yeah.
Just okay. Please.
हेलो,
Yeah.
हाँ नमस्कार रामिनेश जी, हम कुछ देर में करें 15 मिनट में, थोड़ा हम बाहर हैं, जस्ट आकर आपको कॉल बैक करते हैं. ओके.
Please keep your mic mute, man. So, yeah, weak law of large number, you can have it from PPT also, right?
Okay. Ma'am, only one doubt, ma'am. X minus x minus mu, modulus of x minus mu. If I write greater than delta.
Yeah, what is that? X bar minus mu is
greater than delta. Yeah, that will be less than equal to sigma square by n delta square.
Yeah. Yes.
So that form, yeah.
Sigma square by n delta square. So here it is variance of something. Yeah. What?
Okay. Then next formula will be x minus mu, modulus of x minus mu less than delta. There only I have doubt, ma'am. Should it be greater than equal to 1 minus sigma square by n delta square or less than equal to? This is where I have the second one only I have doubt.
This one only. Why it is so? It's a complement, no?
So it is greater than equal to 1 minus sigma square by n lambda square, is it?
See, it is, let's say x minus mu is somewhere here. Okay, and let's say this is delta. Okay. Now you are saying x minus y is less than delta. So you will be lying in this part, right? For that, some probability is there. Okay. So you know this later on. But yeah, this one corrected. C. Let's say your delta is lying there. You know this probability, right? You are very clear with this probability that this one is correct, right?
Yes.
So probability that x bar minus mu is greater than delta. Let's say your x bar minus mu will lie somewhere here, right? Isn't it? X bar minus mu is greater than delta. That means it's lying on right side of the
right
delta.
hand side. Okay.
For that, probability is less or equal to n sigma square by n delta square.
Yes.
Right? So, once someone asks this probability, then what should it be? Its upper limit will be 1 minus this one. Okay.
Okay. So, okay. Got it.
So, same thing also we have discussed there. Okay. Fine. No problem. Sir also has discussed in the lecture. Okay. So, let's move to the next one. That is what? Question number 30. Find the minimum value of n such that the sample mean lies between 2.5 to 3.5 with the probability more than 0.95. You say, okay. So similar question, isn't it? How will you solve this question? Yeah.
First, we will find the value of delta.
Delta is needed here, or this one is Chebyshev?
I
No?
think this one
Sigma.
In combination of weak law of large number and Chebyshev, we can solve this.
Yeah, but I don't think so. There is a need of weak law of large number here.
Okay.
So we have been asked what probability that our x bar is lying in the range what?
2.5 to 3.5.
Yeah. So x bar is lying in the range 0.25 to 0.35.
No, ma'am.
2.5,
2.5.
right?
2.5.
Sorry. That it's lying between 2.5 to 3.5 is what? More than 0.95. This is given, right? More than or at least?
More than.
More
I
than.
don't think.
Yeah, it's more than. So this is given. And asking for what is the what are the values of n?
Yeah, the minimum value of n.
Minimum value of n. So do we know the mean of the variance, mean and variance here? Yes. Right? Nu is
Yes,
equal
sir.
to 3. So just subtract it first with the 3 whole term. 2.5 minus 3 s are equal to x bar minus 3 s are equal to 3.5 minus 3. Now you will get something. So this is what? Negative 0.5. This is what? 0.5. So which form you will use?
Modulus.
Probability that, modulus x bar minus 3 is less or equal to 0.5 is greater or equal to 0.95. So from previous question, we have calculated x bar minus 3 less or equal to 0.5 is greater or equal to 1 minus 36 by n, right? So do we know this? This is nothing but 1 minus 36 by n, and this is 0.95, which should be greater.
Yes.
Which should be greater here now. You know two bounds for the same thing. Right? From the previous question, modulus of x bar minus 3 less or equal to 0.5 is greater or equal to 1 minus 36 by n. So which one is your lower bound now? This one or this one? Now you know 1 minus 36 by n and 0.95. Which one is the stronger bound?
0.95.
Why?
Ma'am, of course, 0.95 is very bigger.
Because?
It seems bigger. It seems bigger.
What if this turns out to be 0.99?
Ma'am, then how will you decide?
Because we want more than 0.95. That's why we decide like that. We want more than 0.95.
Oh, yes, yes.
Okay. So now it's easy to solve now. Just subtract 1 from both the sides and what we will get 36 by 9, right?
Ma'am, we can just equate it's equal to and then find n and tell that's the least number values n.
Okay, if you equate it, then you will get n equal to something, right?
Yeah, and that should be the least value.
Isn't it? Will it be the least one?
No.
Are you sure that will be the least one? So
yeah, previously some other questions we have discussed. Like
in some particular question, you might get that it's like, see, when you take equal to sign, whatever the number is, that may or may not be your minimum or maximum. Whenever the question are for minimum or maximum, just take care of that. So that's why inequalities are important there. So okay, let's just solve it. Greater or equal to 0.95, that means 0.05, right?
Yes.
So negative sign is there, so I will just multiply, right? Sorry. It will be negative sign on both sides, right? If I subtract from both the side 1 minus 1, then it will be negative on both sides. Then just that's it. So what will be your n?
720.
N is less or equal to, greater or equal to what?
720.
Yeah, greater or equal to 36 by 0.05. And that is, 720. Greater or equal to 720. Fine. So this is your lower bound or upper bound for n?
Ma'am, there both side it was negative sign, no? So why we are changing the symbol actually? It is in this case both side negative sign is there, no? 36 by n and minus 0.5.
Yeah. Then what's your question?
So why we are reversing the signal, like greater than to less than?
Okay, as discussed in the last session, minus 4 is okay. 4 is greater than 3. Or let's say minus 4 minus 3, what is greater? Minus 4 is less than minus 3, correct? Let's change the sign. 4 and 3. Now, is it correct?
Correct.
It's not correct, man. 4 is greater than 3, no?
Correct. Okay.
So the real line, just whenever this negative confusion is there, just imagine real lines or take the numbers, will be more clear, right? Why to change sign? Okay. So n is greater or equal to 17. Yeah.
How this greater than equal to sign came?
Which one? This one?
Yes, ma'am.
Okay. So from this was given to us, right? This information, this equation number 1, let's say, is given to us. Okay. And this I brought from the previous question. Okay. From previous part, we got this one. Now you have two inequalities for the same question. But we are being asked that what is the probability that this part will be more than 0.95. So I just made it smaller here and take the sign here. Okay. That's fine.
Ma'am, I didn't understand.
Oh. So let's say you have two probabilities, right? Probability that x bar minus 3 less or equal to 0.5. For this probability, for this one and for this one, you have two bounds. This is bound 1 and this is bound 2. Fine. Both are the lower bounds. Both are the lower bounds for your given probability.
Yes, ma'am.
Now, remember the question. What was the question? What is the probability that this x bar minus 3 will be less or equal to 0.5 will be greater or equal to 0.95? Okay. This probability, I want greater or equal to 0.95. And now I got, and we want to find what are the numbers, like how many random variables do you need to guarantee that this probability will be greater or equal to 0.95. So to find n, I just bring out the general probability, general lower bound. Then using that both of the bounds, now I was confused that 1 minus 36 by n, and this is another bound. Now I have two bounds. Then how to solve this confusion? So just remember the question. It asked us what is the minimum number of n such that the probability should be greater than, more than 0.95. So this is also bound, this is also bound, but I want this to be the lower bound of my probability. So I made it like this. Is it like convincing or not? Still any doubt?
No, ma'am.
Okay. So what about the next question? In a telecom system, each data file consists of 500 bits. Due to noise, each data bit received may have an error with probability 0.1. It is assumed that the bit error occurs independently. Suppose y represents the total number of bits without an error in a certain data file. Which of the following is true? Okay. Anyone solve this question?
Ma'am, binomial 500 0.9.
Okay. Let's start with it. So, according to the given question, we have two random variables, right?
Yes.
Okay. So there are some 500 bits, and we are looking for the errors, right? So let's say x is a random variable, which is denoting error in, like it's checking error in bits. So for x, there will be two values, right? Yes or not? Like
yes.
Either there will be error or it's errorless, right? So x will take either 1 or 0, two values, right? If there is error.
Yes, ma'am.
And if not, fine. So given that the probability of error in one bit is what?
0.1.
Yeah, error in bit, error in one bit is equal to 0.1. Fine. So can I say it as a probability x is equal to 1?
Yes.
Is equal to 0.1 as I have defined it like that. Okay. Now, what is y given there? They have given that y represents total number of bits without an error. Okay. Y represents total number of bits without error. So just tell me how many bits you were checking for?
500.
500.
So n is equal to 500 and y is y is denoting total number of bits without error.
300.
That means probabilities x is equal to 0. That is without error is 0.9. Okay, fine. So out of 500 bits, y is calculating how many bits are without error. Which distribution it might be?
Binomial.
Binomial. If y is following binomial, then it will need two parameters, n and p, right? P
Yes.
is probability of whatever is we are calculating without error, like bits without error. Fine. So n is 500. That's not a problem here. Okay. N is equal to 500. And what will be the p here?
0.9.
0.9. It's the probability of bit without error. 0.9. Okay. Is it fine? So my y is following a binomial distribution with n is equal to 500 and p is equal to 0.9. One more thing you can take a note of is that some of Bernoulli random variables will give you binomial, right? Fine. So this was for the question number 14. Now question number 15, which is quite interesting. Anyone tried that question?
Yes, ma'am.
Okay.
Ma'am, option 1 also can be correct, isn't it?
Bernoulli? No, it's not a Bernoulli. It's see, Bernoulli is distribution which will say answers whose outcomes will be two only, either yes or no, kind of things. When you say it's a Bernoulli, but just check what random variable is denoting. It's denoting total number of bits.
No, ma'am.
So
Kind of like if we toss once, that is Bernoulli, but if we toss 500 times, that becomes binomial.
Yes, exactly. So it's represent total number of bits without an error. So to calculate that, it will take any number of values from 0 to 500, right?
Okay, ma'am.
Using CLT, central limit theorem, find the approximate probability that there are more than 53 errors in a certain data file. Enter the answer correct. Okay. More than 53 errors are there. That means what is it asking?
Y greater than 53.
Y greater than 53. But just remember, now for this question number 15, your variable will be changed little bit. How it is?
Yes, ma'am. Because it is giving greater for error, so we will take 0.2.
Yeah, probability that your y is greater than 53, that's fine. But now your y is not a binomial with 500 and 0.9. Why? This y was giving you total number of bits without error. They asked number of errors greater than 53. So that means this y is calculating numbers of errors, right? Number of errors.
Then it will become binomial 500.1.
Exactly. Very good. Y is binomial 0.1. Okay, fine. So, question number 15, right? X will be the same as discussed above. Now your y will be changed for binomial 500 and 0.1. And y is what actually? Can I write it as a summation of xi? Where x is what? Error in a bit. Like this. xi will take 1. My xi's are defined as 1 and 0 when error in bit or else, right? Okay, fine. Do you agree with that?
Yes.
I have just repeated it. So y is equal to nothing but the summation of xi. Fine. So can I know what is the mean for y? If it is a binomial random variable,
NP.
what is NP? Okay.
50.
500 500 multiplied by 0.1, which is equal to 50. And do we need variance here? Yes.
Will be 45.
Yeah. Sigma y will be p into p minus 1, right? Sorry.
0.9 into 500.
N into q.
50 into 0.9.
NPQ basically.
0.9.
Yeah, NPQ or whatever you say. NP into 1 minus p. 1 minus p. Fine. So NP we know that it is 50 and rest part is 0.09.
No, ma'am, 0.9, yeah. 45.
0.9, yeah. 45. Okay, so how to use CLT? We need to calculate probability y greater than 53. How to use
No, variance
CLT?
is sigma square. Okay.
Yeah, it's a sigma square.
And now we'll subtract and divide by variance, mean and standard.
Y minus 50 upon root 45.
Yes.
Greater than 53 minus 50 upon root 45. Sorry.
Yeah, square root 45, then what?
Greater
than
45.
53 minus 50 divided by
root 45.
root 45.
And this side we can mark as Z.
What?
We can call the
This side y minus 50 on root 45, we can call it as Z.
Okay. So z greater than, this is what, 3 by square root 45, right?
Yes. Now we can take the
Right.
FZ value.
What?
FZ value. Normal
Yeah.
table value.
Normal table. FZ
1
value.
minus FZ.
Okay, that's correct. But mathematically, we do not write it like this. We take it as a
Yes,
probability that y minus 50 is greater. Okay. So just take care of that. Even though you are correct, if it is a like written exam, you will lose your marks. That do not have any meanings. Okay, probability greater z greater than what? 1 upon square root 5, isn't it?
Yes.
15. Okay, fine. So now this is z greater than 1 upon root 5. Now
1 minus p z.
1 minus z less than 1 root 5.
1 by root 5.
Yeah, just be careful. We do not. Why we change? Why we change this as a 1 minus? Anyone?
Or less than equal to.
Yeah, but why to change it like that?
We are bringing it into CDF form, ma'am.
Yes, exactly. CDF format. So fz of 1 upon square root 5, that value might be given to you 0.67, right?
Yes.
And that will be 0.33. That's it. Okay.
मैडम अगर यहाँ पे less than होता, sorry, if z is less than 1 by root 5, z is probability z less than 1 by root 5, so 1 minus नहीं करना पड़ता. We don't need to do 1 minus.
Exactly, because it's a CDF. It's
Then,
already in CDF format. Yes, correct.
okay, then we directly have to calculate fz 1 by root 5.
Yeah.
So 0.67 would be the answer.
Mom?
Yeah. Yes.
Mom, why didn't we use y minus n mu by root n sigma?
Y minus?
N mu by root n sigma formula for CLT.
That's what we used here, right?
Mom, y minus n.
Y minus n nu. Okay.
By root n into sigma.
By square root n sigma. We have used mean of y and variance of y. Why we have not used? Is that your question?
Yes, ma'am. And we have this formula as well for CLT, right?
Yeah. So nu and n sigma, when will it come into picture? When you are dealing with single x. Here your y is already summation of x1 to xn. See, 1 to n. So here we were using the CLT for y, which is the sum of x1 to xn to x1 to xn, right? So in that case, we have directly calculated mean and variance for y. So we have liberty to use directly mean of variance, mean and variance of y. Or you can do the same thing in this form, that probability that, see, what you are asking, in that case, instead of y, I should write what? X bar.
X bar.
Right? It's a sample. No, it's a sum of random variables, right?
Yes, just x, ma'am.
So just don't take it as x bar, or just take capital X. But just understand, just be clear that this is sum of random variables, okay?
Sum of 500 x's, right, ma'am? In this case.
Yeah, yeah. Sum of 500 x's minus. So what we do here, according to, as you said, n into p, right? N into p. Why p? So it's nothing but p is mu here, that is mu x here, okay? Divided by sigma x, okay? Or n sigma x, okay? Are you getting square root n x? Sense, right?
Yes, ma'am. Square root.
Okay. Square root n sigma x, okay? And then you move ahead, right? Similarly, what I did, so you can take it as a y also, because in this particular question, our y is denoting summation of x, right? So y minus n nu x upon square root sigma x, okay? That is equivalent to say that y minus n nu x is what? If you check it, nu y, mean in this particular format, we have used y minus nu y. That means mean of y divided by sigma y. So just if you look carefully, your mean of y is what? N into p. Okay. X is what? X is a Bernoulli random variable, right? Bernoulli with probability p, right? So what is the mean of x? P, right? So np is nothing but n times mean of x, isn't it? And what about variance of y? It was n into p into q, right? Now just remember variance of x. What was it? P into q. N into variance of x. Are you getting what I want to say? So if you are using mean and variance of x, then you have to take care of this n square root n, okay? But if you are directly calculating the mean and variance of this y, then no need. Directly give the values of mean of y and variance of y, okay? So they are the same.
Ma'am,
yes. Huh.
If we have n IIT samples and y represent the sum of those samples, then can we use this formula y minus n mu?
Y minus?
This formula for CLT, y
See,
minus.
these both are same. And here we are considering that they are IIDs. It was given there, no?
Ma'am, actually I have confusion when to use this formula and when to use the one that you have used.
Okay. Whatever you want to use, I am just saying that both are equal. You can use anyone, anywhere. But just be careful whether you see in some of the questions you will be given with this new y, right? You will be this new y will be available to you, and sigma y is available to you. Then you will then go with this formula. In some of the question, mean of x and sigma of x and n is given to you. In that case, you can go with this one. But in this particular question, both are given to you. Like both the information is available to us. So anyone you can use, okay? According to whatever the given in this question, given information, we can do like that. Okay? So that was all about today. Thank you. Any questions? Okay, thanks.
Thank you, ma'am.